Hello, juniors. Okay, so today we're gonna cover some applications of linear functions. We're gonna do some exercises about linear models, that is, how we can apply linear equations to solve real life situations. Okay, so just to make a quick recap of what we were studying yesterday. Yesterday we've seen the different forms of expressing the equation of a linear function, right? Just to show you something, if you see and you go to your formula booklet, which is this document, which is available in the Google Classroom. This is the official formula booklet of the IB for this program that you're studying. So if you go to topic 2, which is functions, you'll see that in topic 2, here you have all the three different forms of equations of a straight line. Remember the first case, this is the gradient intercept form. Remember, gradient intercept form. This is the general form, and this is the point slope, right? Or gradient point form, in which we're given a known point and the gradient of the function. Okay, this is just for you to remember. You don't have the names here, so you need to remember which one is which. But that's easy to remember if you know what each of the parameters represent. Okay, so go back to the assignment. This is electronic assignment number 12, linear models. The objective for this class is to apply the concept of a function as a mathematical model. So it says, a linear function which describes the relationship between two variables which are connected in real life is called a linear model. A linear model is used to analyze and predict how the dependent variable will change in response to the independent variable changing. Remember those concepts, independent variable and dependent variable. So let's see this example. It says, the table shows the relationship between the number of days a car is rented and the cost of the rental. This is similar to I think it's the same example we've seen at the beginning in the investigation. So it says, so we have number of days and cost in euros. A, without plotting a graph, show algebraically that the relationship between the number of days and the cost is a linear relationship. Okay, so without drawing this, how can we determine if this corresponds to a linear relationship? Remember the concept. If the rate of change is constant, then we may conclude that this is a linear relationship. So, if rate of change is constant, then we're talking about a linear relationship. Okay. So, how do we determine if the rate of change is constant? You just need to find the difference between the independent variable first. This would be 1. This is 1. This is 1 and 1. 2 minus 1, 1. 3 minus 2, 1, and so on. The same thing for the dependent variable. This difference is 30.25. Then this is again 30.25. 30.25, and finally 30.25. So if you calculate the rate of change in each case, the rate of change would be rate of change is 30.25 divided by 1. Remember, rate of change is the same as the gradient of the line, which is 30.25. Okay, so that's how we show algebraically that the relationship is a linear relationship. Okay, so this corresponds to a linear relationship. Then for part B, find a linear model for this relationship. Give your answer as a function in gradient intercept form. Remember, gradient is m, intercept corresponds to the y-intercept. So we're asked to find the equation using the gradient intercept form, which is y equals mx plus c. Okay, so y equals mx plus c is what we need to find. We already know the value of the gradient, which is the rate of change, right? So the value of m is 30.25. But we still need to find the value of c, which is the intercept. In order to find the value of c, we can plot in any of the numbers, any of the points of this graph. We could use this one, or this one, or this one, and so on. It's easier if you pick the smallest numbers, so we're going to use this as our given point. So we're going to write y is 30.25. Our slope is also 30.25. X in this case is 1, it corresponds to the first day, plus c. So then we calculate the value of c, and this would be c equals 0, right? Because 30.25 cancels out. So the equation of our line is 30.25 x. And that's it. Plus 0. We don't need to write the plus 0, so this is the answer. Which, if you think, makes sense, right? Because how much will the cost of the car be if I rent the car for 0 days? If I rent the car for 0 days, the value of x would be 0, so the cost would be 0, which is logic, right? Okay, finally, part C. I'm going to do it here, part C. Find the cost of renting a car for 7 days. You see that now that we have the equation, we can use this model to predict the cost for any number of days. We could say 7 days or maybe 100 days if we want. This is a general model that would let us predict. And we will not waste time doing here 6, 7, and then calculating the rate of change in each case. Okay, so by using the same model, I'm going to say that y for day number 7 would be 30.25, and instead of x, I'm going to write 7, corresponding to day number 7, and we get the value of y, which is 30.25 times 7, 211.75. Remember, unit of measurement, euros in this case. So that'll be the cost of renting the car for 7 days. Okay, let's keep on with the next example. It says a video streaming service charges a monthly service fee of £6.99 and an additional £0.99 for each 24-hour download rental of a premium movie. The total monthly cost of this service in British pounds is f of x equals 0.99x plus 6.99. So in this case, we're given the linear model, where x is the number of premium movie rentals that month. Okay, so part A. Find the total monthly cost for a month in which there are 5 premium movie rentals. Okay, so what will be this information? If we look at our equation, it says that x corresponds to the number of premium movie rentals that month. So what we're given here is the value of x, which is 5, right? So for the first part, we just need to calculate f of 5, which will be the cost of renting 5 premium movie. And this would be 0.99 times 5 plus 6.99. So f of 5 is equal to 0.99 times 5 plus 6.99. So this would be pounds 11.94. Remember, people, you can pause the video if you want to try solving this by your own, and then just keep on watching this in order to see if you did the right thing. Okay, so that's it for part B, for part A, sorry. Then part B, find the inverse of the function and tell what x and the inverse function represents in this function. Okay, so this is kind of a review of what we studied already. Remember, to find the inverse, we first write the equation using y, 0.99x plus 6.99. Then the second step is to change the variables. This would be y plus 6.99, and then we solve for y. This would be x minus 6.99 equals 0.99y. So finally, x minus 6.99 over 0.99 equals y. So our inverse function is x minus 6.99 over 0.99. So this is an inverse function. This is the first part of the answer. Then it says, tell what x and the inverse of f represent in this function. Okay, so remember that in the first scenario, we said that x represented the number of premium movie rentals that month, and f of x represents the total monthly cost of the service. So in this case, the opposite occurs. We're gonna say that x represents the cost, right? The total monthly cost. Total monthly cost. And f minus 1 of x, the inverse of f, represents the number of premium movie rentals, in a month. So this equation would be useful if, for example, we go to the cashier and the cashier tells us the total cost is of, I don't know, 20 pounds. So you want to think, how many movies did I rent that month? So you're going to substitute x with 20, and then you're going to calculate how many premium movies you rented that month. Okay, so I think that's where we're going to be asked for part C. It says, find the number of premium movie rentals downloaded in a month where the total monthly cost was this. Okay, so yes, in this case, we're going to use the second equation, as we already have this variable on its own, so it'll be easier to calculate. So we're going to write f minus 1 of 18.87, which is the total monthly cost, equals 18.87 minus 6.99 over 0.99. So then by using our calculators, we can find this number, which would be 18.87 minus 6.99 over 0.99, and you get 12. That means that you rented 12 premium movies. Okay, so it seems that this person was going through the quarantine time, right? Because watching 12 movies in a month is kind of a big number. Okay, so that's it for this example. I hope you could understand this correctly. Let's move on with the next one. I think this is the last one before we do an analysis. It says, there is a linear relationship between degrees Celsius and degrees Fahrenheit. Remember, this example was at the beginning of this topic in electronic assignment number 10. We talked about the relationship between degrees Celsius and degrees Fahrenheit. Now we're going to find an equation that relates both units of measurement. So it says some equivalent values are shown in the table below. So you have degrees Celsius and degrees Fahrenheit. Part A. Find a linear model that relates the temperature F in degrees Fahrenheit to the temperature C in degrees Celsius. Give your answer in this form, which, if you realize, this corresponds to the gradient intercept form, right? Y equals, this is the same as saying y equals mx plus c, where m and b are constants to be determined. Okay, so if you pay attention to the exercise, this is already telling us that this is a linear relationship. So there is no need to prove if this is actually a linear relationship. We we are already given the information that this is a linear relationship, okay? So, if I want to find this equation, f of c equals mc plus b, what should we do first? First of all, we need to determine the slope or the gradient, and then we need to determine the y-intercept, right? In order to determine the slope, remember we have this formula which is also available in the formula booklet over x2 minus x1. So we can pick any two pair of points from this table and calculate the slope. So we can grab the first 2 points, and this would be 59 minus 32 over 15 minus 0. So the slope equals, do this in the calculator, 59 minus 32 over 15. This gives us 9 over 5. Okay, so that's the value of the slope. And then we need to calculate the y-intercept. To calculate the y-intercept, we can pick any point from the table. I always suggest picking the easiest one. So we could say that f of 0 is 32 equals m, which is 9 over 5 times 0 plus b. So this eliminates, this is 0. So 32 equals b. So finally the equation is f of c equals 9/5 c plus 32. So this is the general equation that lets us convert degrees Celsius to degrees Fahrenheit directly, okay? So if, for example, you want to know how much is, let's say, 90 degrees Fahrenheit, or how much is 100 degrees Celsius in Fahrenheit. So what you're going to do is just plug in the value of 100 here and you get the value. Okay, so we can make the try here. F of 100 is 9/5 times 100 plus 32. So this is 9/5 times 100 plus 32 plus 32. This gives us 212. That means that water, for example, evaporates at 100 degrees Celsius, which is equivalent to saying 212 degrees Fahrenheit. Okay. Finally, for part B, I'm going to do it up here. Part B, it says, use your model to find the temperature in degrees Fahrenheit when the temperature in degrees Celsius is 27. By looking at our table, we don't have the value 27, but we can kind of estimate that this should be around, I don't know, 82 maybe. So we can calculate the exact value by plugging in the value 27 into our equation. So we're asked to find f of 27, which is m is 9/5, x is 27 plus 32. So we calculate f of 27, which would give us 9/5 times 27 plus 32, and this is 80.6 degrees Fahrenheit. And we're just gonna write Fahrenheit. So 27 degrees Celsius is the same as saying 80.6 Fahrenheit. This is a real example, people. So this is the equation to convert degrees Celsius from degrees Fahrenheit, if you want to use it for any other application. Okay, finally, we're going to go back to this problem. If you remember from the first class, electronic assignment number 10, I told you to analyze this particular situation And now that you have a better understanding of linear models, I think we may start answering some of the questions we have here. So remember the problem. It says crates of emergency supplies are sometimes dropped from cargo planes to humanitarian aid workers. Each crate has its own parachute. Pilots must determine the height and the time of the drop that will allow the containers to reach the ground intact. The crate is said to be in free fall during the time before the parachute opens. The functions h and g give the crate's height above the ground, measured in meters, t seconds after the crate leaves the plane. So we first have an equation for the free fall before the parachute opens. If you see, this is not a linear model, this is a quadratic model. That's why we're not answering this part yet, because we're going to see quadratic models later on. Okay, so the second part, with the parachute open, once the parachute open, this crate falls following a linear model. You should already be able to identify this as a linear model. You see that this is written in gradient intercept form, right? So if we try to answer this question, we're going to focus only on this question for now. It says, for the model representing motion with the parachute open, what does -5, the coefficient of t, represent? What do you think this represents? You may pause the video to think a little bit and then come back to answer to hear the answer. If you see, -5 in this model represents the gradient, right? Or the slope of the equation. And since we're talking about gt, which represents, let me see, where is it? G gives the height, crate's height above the ground, right? So what this value of the gradient tells us is how much the crate falls per each second that passes, right? So gradient equals -5, that is meters per second. That is that the crate would fall 5 meters for every second that passes. That's what the -5 represents. Negative because it's falling, and the value 5 means that it's falling 5 meters per second. Okay? Meters per second. So that's what this coefficient represents. Okay, so that's it for this class, people. I hope you could understand the concepts. If you have any questions, you may always ask in the Google Classroom. See you.